screen. Good morning. We will discuss PV diagram, which is one of the properties diagram. Here, PV means pressure and volume diagram for a pure substance. So, previous class we have discussed the PV diagram, that is the temperature diagram. So, in case we have considered the two pure substance, that is liquid state and vapor state, right? So in this case, we will consider the three states of the pure substance. So that is solid state, liquid state, and vapor state. So in this case, what the phase change process is occurring in this case of this pure substance that we will plot in the PV plot, and the different properties we will discuss as per the change of your phase. Okay, so here you can see that it is a piston cylinder arrangement. Here I have kept the solid ice. So as already I have told you that during the checks and the chemical component we are considering it is a single component system. So here the chemical equation is that is for the water or solid ice. So or it may be the vapor that we can write it is the same single component system, that is H2O. Okay, so here we have kept the solid ice inside this piston cylinder arrangement. So inside the pressure, the that is atmospheric, that is equal to the atmospheric pressure. Okay, so here we are giving the heat input. So in this case, what will happen? Ice will be heated slowly, so that its temperature will increase slowly. Okay, so that its temperature will be uniform during the equilibrium process. Okay, the changes will occur in case of the mass of the water, and temperature change we will discuss during the conversion of the different state. That is, suppose it is changing to the solid to liquid and liquid to vapor. In that case, there will be the temperature change. So that one also we will trace in this PV diagram. Okay, or PV plot in case of the coordinate system. Okay, so first I will discuss the temperature increase and the change of that condition of the pure substance. So let us consider the 1 to 2 process. Okay, so 1 to 2 process means initially the solid ice temperature, let us consider that temperature is minus 10 degree Celsius. Okay, so here it is initially it is minus 10 degree and pressure is 1 atmospheric pressure. So initially what will happen, when you are heating this pure substance, the temperature of ice will increase from minus 10 to 10 degree Celsius to 0 degree Celsius. Okay, So in this case, we can say that little bit volume will increase as per the thermal expansion. Okay, so in case of this solid, when we are heating, some expansion, thermal expansion will happen. So that one we will consider. Okay. So in this case, 1 to 2 process, the temperature will increase minus 10 degrees Celsius to 0 degrees Celsius when we are heating. Okay, so that one we will consider in this previous unit. Okay, I will show you that one later on. We will plot. Okay, so next let us consider that process is 2 to process. Next process. So in this case, when your temperature will reach 0 degrees Celsius for that solid ice, at that time when we are giving heat input, so what will happen? Ice will melt into the liquid water. Okay, so that is one phase change process. In this case, your solid ice will convert into liquid water at the constant temperature, that is the 0 degree Celsius, and constant atmospheric pressure. Got my point? Okay, so the melting process will start from the point 2 and it will end at the point 3. So at the point 3, we can say that your condition of the pure substance will be the liquid. Got my point? So in case of your pure substance, that is your water, in this case, when there is the phase change process will be there from the solid to liquid. In that case, what will be happen? There will be the decrease in the volume of the pure substance. So which is the peculiarity of your water. Got my point? In case of the water only, this will happen during the melting process. Your volume will decrease, but for the other pure substance, your volume will increase. Okay, so now we can say that point 3, the condition of the pure substance or water is the liquid water, and your phase change process will occur at the constant temperature and constant pressure. Got my point? So in this case, the solid ice will be converted into the liquid water by observing the latent heat of fusion. Latent heat of fusion. Okay. So solid will converted into the liquid. Okay. Got my point? So as I've already told you, this is a latent heat, means energy consumed during the phase change process. So during the phase change process, whatever energy will be utilized, that term will be given as latent heat. Okay. So if I will show all these process PV coordinate system, then suppose in this case it is the point 1 and this is your point 2. So in this case, what will happen? Your solid ice will, which is at the minus 10 degrees Celsius, that temperature will increase to the 0 degrees Celsius. Okay, whereas your pressure is constant. So this is your pressure constant, 1 atmospheric pressure. So if you are observing here, there will be a small volume increase. Okay, so due to the thermal expansion. Actually, to show this graph clearly, so I have kept this distance more than means I have kept this distance more. Okay, so yeah, but it should be less than this distance. Okay, got my point? So 1 to 2 processes increase temperature minus 10 degrees Celsius to 0 degrees Celsius upon heating. So now come to the 2 to 3 process. As I have told you, 2 to 3 process means it is the patching process. Solid ice will convert it into the liquid. So in this case, your volume will decrease. So somewhat let us consider it is the zero point 0.3. So here you can see that here your volume is decreasing. Okay. So now we will consider the process that is your 3 to 4 process. So in this case, what will happen? Now the condition of the pure substance is your liquid water, sorry, liquid condition. Okay. So in this case, your temperature is 0 degrees Celsius, right? So when we are increasing the temperature in the when we are giving the heat input, in that case there will be the increase of the temperature, that is a 0 degree Celsius to 100 degree Celsius. Okay. So in this case, there will some increase in volume due to the thermal expansion process, but there is no phase change process. Okay. So this is 3 to 4 process. So somewhere we can say it is 4 process. Got my point? So now coming to the 4 to 4 to 5. Okay. So 4 to 5 means in this case the temperature of water is already 100 degree Celsius. So in this case, when we are giving the heat input to this compressed pure substance, so what will happen? There will be the phase change process will start. That means in this case, liquid will converted into the vapor. So that will happen at the constant temperature and the constant pressure. Okay. So that is your 1 atmospheric pressure and 100 degree Celsius. So in this case, what will happen? There will be the large increase in the volume of that pure substance. So we can say that large increase in volume means somewhat here it will be. So it is your 5. So large increase means we can draw like this. So please join all the line dot or these steps, so it will become a line. Okay, so here it is the 4 to 5 process. So in this case, your volume, large volume will increase. Okay, so next we are increasing the uh, temperature heat input. So let us consider that that process is 5 to 6. So in this case 5 to 6 means we are increasing the temperature. Let us consider that is the 250 degrees Celsius or more than that one. So in previous PV diagram, that is TV diagram, there we have taken 300 degrees Celsius. Here also you can take that one, or I have taken here 250 degrees Celsius. So here you know that in this case there will be the vapor will heated, the temperature will increase 100 degrees Celsius to 250 degree Celsius. So in this case, your volume of vapor will increase somewhat. We can say this is in this point. Okay. So in this case, we can say that is the superheated vapor. Okay. So this process I have considered, all the process I have considered at the constant pressure, that is your 1 atmospheric pressure. Okay. So now suppose we have considered the process, this conversion of solid to vapor for the different pressure. So for the different pressure, in this case, we will get the plot like this. Okay. So similarly here, if you are joining all the dots, all the state, so we will get the curve like this. So which is the dome shape. Okay. So टीवी प्लॉट को याद कीजिए, वहाँ पे हम ऑल दी स्टेट को ज्वाइन कर रहे थे. यहाँ पे भी वही है. Suppose it is at the 1 atmospheric pressure. Above that one, this is 2 atmospheric pressure. Like on your pressure is increasing. Okay, up to the critical point. Okay, got my point. तो इसको अगर हम joint करेंगे, so here it is your saturated liquid line. Okay, saturated liquid line, and this will be your, if you are joining all the state of the saturated vapor, so then this will be give you the saturated vapor line. Okay. Okay. So here your 2, 3, 4, and 5 states are known as your saturation state. Okay, saturation states. Okay, so this is the state 2. So it is the saturation state, means from that your phase change process will occur. So state 2 is known as your saturated solid state. Okay, got my point? So here from this state, your solid will converted into the liquid at the constant pressure and constant temperature. Got my point? Then there will be the state 3. State 3 is known as your saturated liquid state. Okay, and state 4 is also known as your saturated liquid state. क्योंकि यहाँ पे 3 and 4, यहाँ पे देखिए ये आपका 2 से सॉलिड टू लिक्विड हुआ, यहाँ पे कंडीशन ऑफ द pure substance will be the liquid. In this case also your condition of the pure substance will be the liquid. So ये दोनों को हम बोलते हैं saturated liquid state. This is also saturated liquid state. But the difference is that state 3 is known as your saturated liquid state with respect to the solidification, and state 4 is known as your saturated liquid state with respect to the vaporization. Okay. So now state 5 is known as your saturated vapor state. Okay. So saturated vapor state means when it is the state when you are condensing the pure substance at that time, that will convert it into the liquid. So this is known as your saturated vapor state. So if you are observing in this PV diagram, so when all the state are joined together, so that will be converted into the line. So let us consider that is the state 2. State 2 is your saturated solid state. So when you are all the state we are joining, then that will give you the saturated solid line. And here if you are joining all the state 3, then it will give you the saturated liquid line. Here if you are joining all the state of the 4, okay, so it will give you the saturated liquid line. So ये दोनों को, these two line is known as your saturated liquid line. Okay. So we have seen all the state and all the lines. Okay. This is state that line which joins state 2 is known as your saturated solid line. Line. Okay. So in between this saturated solid line and saturated liquid line, that pure substance will be coexist in the form of the solid and liquid mixture. So it will happen in case of the equilibrium condition only. यहाँ पे solid and liquid मिक्सचर के हिसाब से रहता है, जैसे कि हम इसको जानते हैं, ये है लिक्विड वेपर मिक्सचर में रहता है ना, 4 to 5 के बीच में, है ना, ये डोम के अंदर जो है, that condition of the pure substance will be the it will be the mixture of liquid and vapor. Okay, so here you are observing one line that is known as triple point line. Okay, so in case of the PV diagram, the triple point will be the one line here you are observing. Okay, so in this case, 3 point line means in this case, all the three phase will remain in equilibrium, or we can say that all the three phases, solid and your liquid, okay, and your vapor will exist in the equilibrium. So here you can see it is your left of this one, this is the solid region, and this is the liquid vapor mixture, and this one is the solid and vapor mixture. It is your solid and liquid mixture. Okay, so this will coexist in the equilibrium. Okay, so below this pressure, so it is at the constant pressure, right? So below the triple point line, the pressure, uh, um, if you are decreasing, so in this case, what will happen? In this case, directly liquid will be. Um, so below this line, I can say that it is a solid and vapor mixture. Below this line, we do not have any liquid phase. So in this case, if heat transform will be there, so in this case, directly solid will be converted into the vapor. Okay, so that is the condition triple point line. Okay, so I think now you have understood the PV diagram for the pure substance that which we have considered is the water. यहाँ पे हम वाटर किस लिए कंसिडर करते हैं, क्योंकि अब जो पावर प्लांट साइकिल हुआ या जो भी थर्मल पावर प्लांट हुआ, वहाँ पे हम ज़्यादातर वर्किंग फ्लूइड वाटर ही यूज करते हैं. ओके, so that's why we have discussed. So at the at the different temperature and pressure, what will be the properties of your pure water that we have discussed, and we can take the data from steam table, and we can calculate as per your requirement. सपोज आप टर्बाइन का वर्क आउटपुट फाइंड आउट करना चाहते हैं, so that is your W. So in that case, we can say that that will be difference of H1 minus H2, है ना. तो ये H1 and H2 कैसे मिलेगा, ये है आपका एंथैल्पी, है ना, एट इनलेट ऑफ द टर्बाइन, एट एंथैल्पी एट द आउटलेट ऑफ द टर्बाइन. ये कैसे मिलेगा, आपको अगर प्रेशर टेम्परेचर पता है, तो as per that one you can find out the H1 and H2. जैसे कि इनलेट है आपका मान लीजिए सैचुरेटेड वेपर है, तो इसमें आपको H1 का वैल्यू मिल जाएगा. सो कंडीशन क्या होगा, दैट इज योर Hg, गैसीय फॉर्म में होगा. अब आइए H2. H2 है जो आउटलेट ऑफ द टर्बाइन में जो use किए हैं जो steam which is created on your plate, that will be converted into the solid vapor and liquid mixture, or directly it will be the liquid mixture. So in this case, sometimes we are considering that is the HF और HF means liquid condition. अगर हमें HF पता है, HF पता है तो यहाँ से हम work output find out कर सकते हैं. Got my point? Okay. So like that, so one can refer the steam table, and he can find out what is the work output from the turbine. So this is we can say by knowing the quality of the steam, we can find out the work output or power output of the particular plant. Okay, so that's why we are studying all these properties. Okay, got my point? Now coming to the this is one diagram, PV diagram. So here I have shown the isotherm. Okay, so the what is that one? I will discuss to you here. So if you are observing here, it is the reverse process. That reverse process means in this case, what we are doing, we are compressing the vapor, right? So, that compression process is the slow compression process. क्यों स्लो कंप्रेशन प्रोसेस कंसिडर किया जाता है ताकि देयर विल बी thermal equilibrium and chemical equilibrium and mechanical equilibrium. So all will be in the quasi equilibrium process. So that we can better study the process. Okay, practical application के हिसाब से हम उसको अच्छे से कर सकते हैं. ठीक है. So here we can say that vapor is kept inside the piston cylinder arrangement, and which is compressed slowly and isothermally. So in this case, if you are observing here, your pressure is increasing. So here initial point, and it is increasing. So due to the increase of the pressure, there will be the but temperature will also increase. Okay. So that compression process will be reach up to the vapor state, that is your point B. Okay, this is your saturated vapor state, that is your point B. If the compression is again continue, so what will happen? There will be the condensation will occur. Condensation will occur means in this case vapor will condense to the liquid. So that condensation will occur at the constant pressure and constant temperature. Okay, because it is a phase change process. So in this case your pressure and temperature will remain constant. This in this case it is a liquid vaporization, right? So somewhat at the middle of this line, there's liquid and vapor will be exist in equilibrium. Okay, then so here if you are observing, suppose again we are compressing the liquid. So in this case, for the compression, we may require the large number of pressure. So all of you know that when you are compressing the liquid, there we will have the large pressure is required to compress that liquid. So that's why that this line is vertical. Okay. So because of this large increase in pressure, the CD is almost a vertical line. Okay. So here your ABCD is known as a isotherm of a PV of a pure substance in a on a PV diagram. Okay, on a PV diagram. So ABCD is the isotherm of the PV diagram. Okay. So similarly, if you are increasing the temperature, so what will happen? Your BC will decrease. BC will decrease. So at the point when you are increasing the temperature, that will be at the particular point, there will be directly that vapor will be flashes into the liquid without any liquid vapor mixture. So that point is known as a critical point. So if you are plotting this graph, which is plotting the line which is passing through this point, critical point, so that we can say this is the critical isotherm. Critical isotherm means in this case, directly liquid will be, directly your vapor will be converted into the liquid. So there will be no liquid vapor mixture. So that is your critical isotherm. Okay. So at this point, the temperature is known as your critical temperature, and pressure is known as your critical pressure, and your volume is known as your critical volume. I think all of you have remembered that thing. What is your critical pressure? Critical pressure कितना था? Any one of you, please tell me. Any one of you, please tell me. Critical temperature? एटलीस्ट वो स्टीम टेबल देखिए जो मैंने दिया था, उसको देख के बताइए.
371.95 degree Celsius.
Okay. Dhruv. Okay. Then critical pressure?
20.06 mega.
And then critical volume?
0.0031.
Okay. Dhruv and Saurabh, they have given the answer. Okay. Then okay. Tell me what is the critical pressure? That is how much?
22.06 megapascal.
Megapascal, right? So it is equal to 2 to 1.2 bar. The critical temperature 37
371.95.
372 नहीं आएगा.
371.
373.
हाँ राइट राइट 373 नहीं तो 4 आएगा. पॉइंट पॉइंट में वैरी करता है, उसको देखिएगा, अलग अलग स्टीम टेबल अलग अलग दिखाता है. ठीक है. 373.95. इसको ये देखिएगा करेक्शन, क्योंकि मुझे लग रहा है ये 374 होगा. तो ये प्रेशर के हिसाब से आपको टेम्परेचर देखनी पड़ेगी. देन स्पेसिफिक वॉल्यूम दैट इज योर 0.00 क्या था 317 मीटर क्यूब पर kg. Okay. So this is your critical pressure temperature. So the line passing through this critical point is known as your critical isotherm. So in this case, the reverse pressure, reverse process we have shown. So we have compressed that vapor, and that compressed vapor is converted into the liquid, and that liquid is compressed at the high pressure. That's why your line is almost vertical. Okay. So in this case, your temperature will increase up to the critical point, that is 374 degrees Celsius. Okay. So this is known as your isotherm. Got my point? So now we will discuss the PT diagram. PT diagram is, that is the pressure and temperature diagram. Okay. So in case of the PT diagram, uh, on the same case, the solid conversion of the solid vapor. Okay. Yeah, let us consider this to 1 atmospheric pressure. So initial, what will happen? The solid ice will the temperature will increase from here minus 10 degrees Celsius to 0 degrees Celsius, right? Okay. So next there will be the 0 to 0 डिग्री में आपका क्या हो रहा है? Conversion of the सॉलिड टू लिक्विड एट दिस 0 डिग्री, तो आप उसको लिख सकते हैं 2,3। ठीक है, यहाँ पे आपका है 1। ठीक है, सो नेक्स्ट देयर विल बी द इंक्रीज इन द टेम्परेचर दैट इज 0 डिग्री सेल्सियस टू 1 डिग्री सेल्सियस। ठीक है, सो दैट इज द 0.4 3 to 4 है ना। Next, what will happen? Next, we will have the your 0 डिग्री सेल्सियस में ही आपका फेज चेंज प्रोसेस अकर हो रहा है, राइट। तो आप इसको ऐसे लिख सकते हैं 100 डिग्री में फेज चेंज प्रोसेस हो रही है वाट में एटमॉस्फेयर प्रेशर में। ठीक है, 4 to 5 हुआ। ओके, सो नाउ 5 to 6 में आपका टेम्परेचर इंक्रीज हो रही है। सो लेट अस टेक दैट इज योर 250 डिग्री सेल्सियस। सो दिस इज योर 6। ओके, तो आप हम उसको अगर इस टाइप का करेंगे, प्रेशर इंक्रीज करेंगे, व्हेन वी आर इंक्रीजिंग द प्रेशर लाइक दिस, ड्रॉ द लाइन। ओके, तो समटाइम्स यहाँ पे आपको ऐसे ऐसे दिखेगा 0.4, ये आपका 1। ये थोड़ा आपका स्टेप पर रहेगा, इस लेफ्ट साइड होगा। ठीक है, तो यहाँ पे आपका इस टाइप का होगा। It is quite difficult to draw this diagram in using this digital pad. So if you are observing here, it is minus 10 degrees, 0 degrees, 100 degrees, 50 degrees Celsius. So, if you are observing here, this line we have joined, this is known as your fusion curve. फ्यूजन कर्व मीन्स इन दिस केस 2 to 3 प्रोसेस में क्या हुआ था. सो यहाँ पे 0 डिग्री सेल्सियस में वी हैव द दैट इज द चेंज ऑफ फेज दैट इज सॉलिड टू लिक्विड. Okay, so that solid to liquid will be that solid will be converted into the liquid by observing a latent heat of fusion. Okay, so when this line are joined together, then this line will be known as your latent, sorry, line fusion curve. Okay, so simply it is the fusion curve. Okay, so when the line is drawn by joining the state 4 and 5, then that line is known as your vaporization curve. And this is your solid region. So left to this one, it is the solid region. Here we can say that solid will be directly converted into vapor. So this is your vapor region. Okay. So directly converted into the vapor with the with the absorbing of your some heat. So that state are joined by the line that is known as your sublimation curve. Okay. So if you are observing here in case of the PT diagram, the triple point is the point. Okay. So in which here all the three phase will coexist. But in case of the PV diagram, that will be one line. Okay. Got my point? So if you are observing in this case, your sublimation curve and vaporization curve for the all these substances are your positive. But in case of the more in case is water, if you are observing that is curve will be the negative. Okay, that but for not all the pure substance. In case of the some pure substance, that this fusion curve will be the positive one. Okay, so this is your what I can say that this is the petty diagram. So can you tell me what is the triple point of water?
0 degree Celsius
Okay,
at 180 m.
so uh, if in terms of the Kelvin, if you are representing that is 273.16 के टेम्परेचर स्केल जो मैंने बताया था ना, है ना, ठीक है, 273.16 Kelvin. Okay, so this is your PT diagram. Now we will draw the TS diagram. TS means that is your temperature and entropy diagram. Okay. टेम्परेचर एंट्रोपी डायग्राम. सो ये डायग्राम ड्रॉ करने के लिए हमें एंट्रोपी चेंज की कंसीडर करनी पड़ेगी, जो कि मैंने अभी तक आप लोग को एंट्रोपी पढ़ाई नहीं है, पर आई थिंक यू हैव सम आइडिया अबाउट दिस एंट्रोपी चेंज. ओके, एंट्रोपी चेंज मींस दैट इज योर डेल्टा एस को आप कैसे लेते थे, दैट इज योर S1
DQIT.
माइनस, हाँ, DQIT से लेते थे, नहीं तो S1 माइनस S2 में लेते थे. DQIT को आप इंटीग्रेट करते थे ना 1 to 2, है ना, दैट इज द प्रोसेस 1 to 2, है ना, ये करते थे ना आप लोग DQIT को, राइट. ठीक है, तो आप ये दोनों ये से आप लोग फाइंड आउट करते थे. ठीक है, पेन और पेपर है तो कैलकुलेटर है तो निकाल करके सॉल्व कीजिएगा ये प्रॉब्लम जब मैं बताऊंगी, ठीक है। So let us consider at the 1 atmospheric pressure, at the constant pressure में हम piston cylinder arrangement में we have kept that solid ice. Okay, so solid ice is converted into the vapor. So that process we have to plot in the TS diagram or TS plot. Okay, so that TS plot is drawn at the uh, कांस्टेंट प्रेशर। सो ये क्या आएगा, आइसोबार आएगा, है ना, आइसोबार होगा, है ना। तो सपोज प्रीवियस कंडीशन को ही लीजिए, चाहे वो प्रीवियस कंडीशन नहीं तो आपका -5 डिग्री लेट अस कंसिडर। Solid ice is kept at the -5 degrees Celsius. Okay, solid ice -5 degrees Celsius we have kept inside the piston cylinder arrangement. Okay, so the mass is, let us consider that is 1 kg. Okay, the pressure is constant pressure 1 atmospheric pressure. Okay, तो यहाँ पे मान लीजिए -10 डिग्री सेल्सियस में आप लिए, so what will happen, there will be the when we are hitting that solid ice, there will be the increase in the temperature, that is that will be -10 to 0 डिग्री सेल्सियस। मान लीजिए यहाँ पे है आपका 0 डिग्री सेल्सियस। Okay, so if you are observing here, there will be the entropy change. Okay, so let us consider it is the H1 and it is H2 because 1 to 2 process, same process are considered. Then there will be the increase, uh, what is increase in the increase in the temperature, है ना। तो 0 डिग्री सेल्सियस में आपका फैन चेंज प्रोसेस होगा, नहीं, राइट, एम आई राइट, आर यू देयर?
Yes,
Yes,
ma'am.
ma'am.
ओके, सो तो यहाँ पे क्या होगा, आपका कांस्टेंट होगा, राइट, 0 डिग्री सेल्सियस में, हाँ, फेज चेंज होगी, सो दैट इज योर प्रोसेस 2 to 3, है ना, कांस्टेंट प्रेशर में हुआ ना। So here we can see that is the entropy is your S3. Okay, so next this is the condition of the pure substance is your liquid, है ना, saturated liquid, saturated liquid with respect to the solidification, and saturate 0.4 is known as your saturated liquid with respect to the vaporization, ठीक है। तो यहाँ पे फिर से इंक्रीज हो रहा है टेम्परेचर, तो मान लीजिए 100 डिग्री सेल्सियस को, है ना। So when there is increase in temperature, there will be the increase in entropy, ठीक है। यहाँ पे आपका S4, so increase in entropy हुआ, ये आपका हुआ 0.4। तो ये 0.4 क्या है, saturated liquid with respect to the vaporization, that means from here your vaporization will start, ठीक है। तो अब यहाँ पे आपका कांस्टेंट टेम्परेचर में फिर आपका फेज चेंज हुआ, है ना, हुआ कि नहीं। फेज चेंज मीन्स here liquid will convert it into the vapor, ठीक है। in between the, in this case there will be the liquid vapor mixture, ठीक है। तो यहाँ पे आपका हुआ 0.5। तो यहाँ पे आपका टेम्परेचर कितना हुआ, यहाँ पे 100 डिग्री सेल्सियस constant temperature and constant pressure. So suppose again we are heating that vapor. So somewhat let us take that temperature, heating temperature is 250 degrees Celsius. Okay. So यहाँ पे अगर temperature increase होगा, obviously there will be increase in the entropy, ठीक है। So 0.6. So it is the vapor, evaporated vapor. Okay. So here it is the saturated vapor, S6, ठीक है। So this diagram we have drawn for the uh, 1 atmospheric pressure. This is the isobar. Okay. So isobars on TS plot. So here we have converted that solid ice uh, uh, into the vapor, separated vapor. There is increase of the temperature from the minus 5 degrees Celsius to 250 degree Celsius. Okay. So now please consider the individual process and find out the what is the entropy change. I think all of you have that pen and paper. Please do this calculation. Okay. So entropy increase of the ice when it is increasing from the minus 10 to 0 degrees Celsius. Okay. So in this case, specific heat of ice is let us consider that. That is, I think all of you have idea. Specific heat of ice is 2.093 kilojoule per kg Kelvin. ओके तो यहाँ पे एंट्रोपी चेंज कितना होगा S1 माइनस सॉरी एंट्रोपी इंक्रीज ना प्लीज करेक्ट मी दैट इज S2 माइनस S1 आप लोग शायद देख नहीं रहे हो ठीक
मैम फार्मूले में माइनस भी जाता है ना
ठीक
फार्मूले में देखिए है तो माइनस उसका तो माइनस डिग्री बाई
it is not audible dear please tell me again
ये फार्मूला लिखिए S2 माइनस S1 इक्वल्स टू dq बाई t इसमें माइनस भी आता है ना माइनस dq
माइनस टी
यस मैम
हाँ वो टेम्परेचर की वजह होगा तो आप लिमिट ले लीजिए ना 1 to से dq बाई टी तो कितना आएगा 1 है आपका 1 कितना है केल्विन में कीजिए टेम्परेचर T1 कितना है टेल मी
263.
0.03 0.03 आ रहा हेलो
हाँ हाँ बोलिए
0.03
0.038
आ रहा है
किलो इंटू 10⁻³
हाँ इतना आएगा हाँ इंटू 10⁻³ कितना आया आपका
0.038 इंटू 10⁻³
नहीं तो 3 नहीं आएगा आप वो जूल में किए हैं या किलो जूल में किए हैं
गुड मैम
जूल है ना हाँ तो जूल है तो ठीक है जूल है तो ठीक है कितना आया सबका यहाँ पे T1 कितना है कितना है 268 राइट आपका वही सीपी ऑफ आइस ये आपका 2.093 हुआ फिर ये आपका लॉन के हिसाब से आएगा तो ये 0.0398 किलो जूल पर केजी केल्विन okay so who has given the right answer all of you have done this one
Yes, ma'am.
okay okay can you tell me the Dhruv next process in next process that is your 2 to 3 process what will be the entropy change
Ma'am, zero limits are same. Sorry, sorry, ma'am. Not zero.
there will be the change of phase na at 0
Yes,
degrees
ma'am.
Celsius there will be the change of phase that means say here in this case your solid will be converted into the liquid by absorbing latent heat of fusion okay all of you are getting or not
यस मैम
okay
Yes, ma'am.
Okay, so next process that is your 1 to 2 गया, अभी वो 2 to 3. So 2 to 3 में क्या हो रहा है? Yeah, you can observe here. 2 to 3 means in this case there will be the change of phase. Solid will be converted into the liquid. So that solid to liquid conversion will be achieved by the latent heat of fusion, है ना? जो एनर्जी ऑब्जर्व हो रहा है वो latent heat of fusion है, राइट? वो एनर्जी यूटिलाइज होके आपका फेज चेंज हो रही है. So that temperature is 0 degree Celsius and that pressure is 1 atmosphere pressure. तो यहाँ पे आपका टेम्परेचर कितना है? 0 डिग्री सेल्सियस मीन दैट इज 273.16 केल्विन हम लेते हैं, आप 273 ले लीजिए, ठीक है. और यहाँ पे लेटेंट हीट ऑफ फ्यूजन कितना है? लेटेंट हीट ऑफ फ्यूजन ऑफ आइस मैंने ऑलरेडी लिखा था, कौन से क्लास में आपको पढ़ाई थी वहां पे लिखा था, फिर भी मैं फिर से लिख दे रही हूँ. ना, तो यहाँ पे एंट्रोपी चेंज कितना होगा?
1.22.
1.22. Who has given the answer?
Ayush Agarwal.
Isobar, okay. So I've got this answer how he has calculated. Okay. So that is your that is your S3 minus S2, or we can say that that is your Q by T. Q है आपका कितना? latent heat of fusion. ये है आपका 334.96 डिवाइड बाई T, that is your 273. 0 डिग्री सेल्सियस में है ना? 0 डिग्री सेल्सियस में, तो ये आपका आएगा 1.22 और 1.23 किलो जूल पर kg Kelvin. Okay, so now consider the process 3 to 4. वैसे कीजिए 3 to 4 क्या है? 3 to 4 means in this case we are increasing the temperature from the 0 degree Celsius to 100 degree Celsius, but the condition of the pure substance is liquid only, but there will be the increase in the entropy. Increase in the entropy means that in this case your entropy will increase from 3 to 4. ठीक है, तो यहाँ पे वैसे यही फॉर्मूला यूज कीजिए. कितना है? यूज कीजिए. यहाँ पे आपका स्पेसिफिक हीट ऑफ वाटर कंसिडर किया जाएगा, कितना है? दैट इज योर 4.187 किलो जूल, सॉरी किलो जूल केजी केल्विन, है ना? ठीक है, तो यहाँ पे डेल्टा एस थ्री कितना है? S4 माइनस S3 विच इज इक्वल टू MCP लर्न, और मैं नहीं लिख रही हूँ वो लिमिट वाला. T2
1.744.
1.744.
Yes.
1.3 आएगा.
हाँ हाँ 1.3
1.3
आएगा.
1.306.
1.310.
1.30.
ओके ओके, ठीक है. तो वैसे आप दूसरा वाला भी कीजिए, करके बताइए. फोर टू फाइव यहाँ पे पेचेज प्रूव हुआ, तो यहाँ पे क्या हो रहा है? लेटेंट हीट ऑफ वेपराइजेशन यूज हो रहा है ना, HFG. तो यहाँ पे ये है आपका Q ना, तो कितना है यहाँ पे? लेटेंट हीट ऑफ वेपराइजेशन मैंने ऑलरेडी लिखा था शायद, किलो जूल पर kg. अब 5 to 6 ना, 5 to 6 प्रोसेस में है आपका 100 डिग्री सेल्सियस से 250 डिग्री सेल्सियस जा रही है ना. तो आप बताइए कौन कौन किया है, आंसर दीजिए।
मैम 4 to 5 6.05.
6.05 ठीक है। अच्छा ठीक है। Who has given the answer?
मैम ध्रुव मेहता.
Okay. Anyone else? Ankit, Ayan, have you got the answer?
Six.
Or are you?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. So, what will be the entropy increase in case of the process 5 to 6?
मैम सी का वैल्यू नहीं दी.
इसमें सी नहीं चाहिए होगा, यहाँ पे टेम्परेचर इंक्रीज हो रहा है ना, और सी का ना, सीपी का आप एक काम कीजिएगा, वो टेम्परेचर में स्टीम टेबल में देख लीजिएगा, है ना,
ओके मैम.
और उसको इंटरपोलेशन करके निकालिएगा, ये थोड़ा प्रोसेस लेंथी हो जाएगा, ठीक है। आपका टेम्परेचर के हिसाब से हम लोग निकालते हैं, प्रेशर तो यहाँ पे कांस्टेंट है ना, 1 एटमॉस्फेरिक प्रेशर, वो प्रेशर टेबल में चाहिएगा, वो टेम्परेचर में देख के आप सीपी वैल्यू निकाल सकते हैं। पर यहाँ पे क्या होगा कि थोड़ा दिक्कत होगा, तो आप सीपी का वैल्यू जो है जनरली उसको हीट जो है ना, जहाँ पे जो हम लोग लिए थे आइस का लिए थे, ये स्टीम का अलग होगा, आप उसको टेबल में एक बार देख लीजिए, ठीक है। So I think all of you have clear in this case. So this is your TS flood. So likewise, if you are doing for the all the isobars, when your pressure is in increasing condition, then this will be the. Okay, yeah. This will be look like this. So to atmosphere. तो यहाँ पे आपका ग्राफ वगैरह सब ऐसे दिखेगा, ठीक है। Got my point? So this is your TS plot. So it is clear, I think. Thank you all. If Jyoti is there, Jyoti, please give me attendance. There are a lot of absentees are there. Only 98 students are attending the class. Okay. So please give me. Thank you all. Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
थैंक यू मैम.